Big idea was you have to have a right triangle with an altitude drawn from the right angle, and we talked about writing the similarity statement based off that picture. So let's see if we can do the first one together, and then I'll let you try the next one on your own. So the first thing is, can you write a similarity statement comparing all three triangles? Somebody give me the name of the big one any way you want. Okay, I heard UWV, sorry. It's similar to triangle. The way I do it is I compare my right angles first. So which angle in there is the right angle? W. So this is the right angle. So on the next names, the middle letter has to be the right angle. So which one's the right angle? Z. So I'll call this triangle 1, triangle 2. This is triangle 1. This is triangle 2. Does that make sense? Okay, so in triangle 1, Z is the right angle, goes in the middle. Triangle 2, Z is still the right angle, goes in the middle. Then you're going to compare the big one and one of the triangles. So big and triangle 1. What angle is overlapping and is reflexive in triangle number 1? U. This angle U is exactly the same in the big triangle and in the one on the left. Where is U at when we named the big triangle? First one. So I call this my reflexive angle, but only for the first ones. So that means that U has to come first here. So it's UZ what? W. Okay, then we're going to compare the big one and triangle 2. And what angle do they have in common that never changes? V. V is the reflexive angle. So if I draw the little triangle or the big triangle, V doesn't change, and V is at the end. So this is my reflexive angle for the last triangle, which means V has to come at the end. So it's going to be named what? WZV. Now, if that is not good for you, then maybe go back and redraw the triangles and think about them visually. Any questions? Okay, then you guys try the next one. Okay, let's check and see how you're doing. So somebody tell me how you named the first triangle. Okay, I heard JKL is similar to triangles. So the right angle here was J, which means I need my right angle then in both of the other triangles to come first. So M is going to come first. My reflexive angle in triangle 1 compared to 2. My reflexive angle then is K. So K is going to have to come next. MK, J. When I compared the big one to the last one, the reflexive angle is L. So L has to come last, which means it's going to be MJL. Okay, so did anybody name theirs different than JKL? Okay, what'd you name it? So LJK. So if you're comparing your answers with the back of the book, just make sure that it's in the same order as what they have here. So LJK means you should have JMK and you should have LMJ. Does that make sense? Okay. Molly, did you name it different? How did you name yours? JLK? No. KJL? Is that correct? Okay, KJL. So then the same thing, you would go KJL, so yours should be KMJ, is similar to triangle JML. Okay, does everybody see how you can compare your answer with the back of the book, even if you don't name it the same way they do? Okay, and so when I grade your homework, that's what I'm doing. I'm checking to see the way I have it written, is it the way you have it written, and if not, then does yours match up with mine that way? Yes. Okay, it has to be in the same order because the angles have to be congruent if they are similar. All right, so that's the first step, just being able to write the similarity statement. Not too terrible, right? The next thing they talked about to come up with these two shortcuts was the idea of geometric mean. And so I didn't explain to you what that was. So let's understand what geometric mean is, and then you're going to have some problems where they're going to ask you to find the geometric mean. And I will warn you that on the test, this will be, on Chapter 8, you will have a part with calculator and a part without, and it's not just bonus. So you will have part of your test is no calculator, and the part of your test that's going to be no calculator will include writing that similarity statement, which you don't need a calculator for anyway, and then this part, geometric mean. So you may want to make a little note to yourself that on the test, this will be on the no calculator part. Of course, the day we review on Friday, I will remind you what's on no calculator and what's on calculator. But yeah, so this will be on no calculator. So if we look at a proportion, and I did kind of set it up telling you that a geometric mean occurs when you have the same number in that diagonal spot of your proportion. So most of the times I don't think teachers teach this anymore, but if I have a proportion, I'm not sure that they talk about this in the lower grades, but this is called the means, and these two are called the extremes. Have you guys seen that before anywhere? Okay, so the diagonal going down from left to right is called the extremes, and the diagonal going up from left to right is called the means. And so when the means are the same, then you have what is called a geometric mean. And you probably talked about geometric mean maybe a little bit in Algebra 1. I'm not sure if you guys did or not. Did you talk about arithmetic and geometric and sequences and series? Maybe? Okay. So you had the idea that geometric is when you're multiplying and arithmetic is when you're adding. Did you guys kind of get that idea when you were dealing with the like 2, 4, 6, 8 patterns and you were trying to write rules, and you did that with my words aren't coming because I don't teach it very often. Anyway, but you get the idea of what I'm talking about. Okay, if it comes to me, I'll mention it. All right, so in that idea, geometric means you're multiplying. And so when you have a geometric mean, it's going to occur when these are the same. And when you cross multiply, then what you find out is that x squared becomes equal to the product of a times b, or the product of the extremes.
You have a geometric extreme too.
Yes, and so then if you are solving for x, what are you going to do? Take the square root, and so you end up with x is just the square root of the product of the extremes. So the definition for geometric mean is, first of all, it's only going to be the positive numbers. So they're reminding you that technically that should be what? Plus or minus, but for our definition for geometric mean, it's only the positives. So it's the positive numbers that you get when you take the square root of their product. And by their product, they're talking about the extremes. So if you multiply the two extremes and take the square root, you'll get the geometric mean. Okay, so again, you can start out writing it like this, and then going here, and then going here. Or you could just take the shortcut and say the definition for the geometric mean is the square root of their product, and just multiply them and take the square root. Okay? So for example, if I had something like a problem where they gave me 3 over x equals x over, let's say, 6. So you could do x squared equals 18, or you could just go straight to x is going to be equal to the square root of 18, because we know it's going to be the square root of their product. And then what is the square root of 18? 3 square roots of 2. Okay, but only the positive. they're going to give you problems like this, where they just tell you, here's two numbers, I want you to find the geometric mean. So again, you could start with this first step, 5 over x equals x over 30, because you're trying to find the geometric mean, so you're looking for this number that's the same. Or you could go straight to x equals the square root of what? 5 times 30, which is 150. Okay, again, this is going to be on the no calculator part of the test, so make sure you can do this without a calculator. So you could multiply it and get 150, or you may want to leave it as just 5 times 30 and start factoring the 30 down. That way your numbers aren't so big. So you have 5 times 30, factor that down, that's 5 times 6. 6 is 2 and 3. So you have a pair of 5s, and so this becomes 5 square roots of 6. Does that make sense? You're welcome to multiply and get 150 and then factor it, and maybe look for those bigger perfect squares. But you could also make it a little easier on yourself and just factor from leaving it in multiplied form. Making sense, geometric mean? Okay, so I think there's one more in there on your notes. No, is that it? Okay, and so then this is the two rules that I wrote on the board and that he went over in the video, and I feel like this was just a little bit too busy, but the video kind of broke it down into the parts. And so here's the first rule that you have on your paper, that the altitude squared is equal to the product of the two parts. So again, if you want to write it this way, h squared equals y times x, you can. Maybe a little easier to write it that way. So the altitude, so again I wrote it on the board, it's altitude squared equals part of the hypotenuse times the other part of the hypotenuse. That's your first shortcut that you can use. Your second shortcut is this one here, and they show it both ways because there's two legs in a right triangle. So you could be looking at leg A, or you could be looking at leg B. So it depends on which leg you're looking at. If you're looking at leg A, then the shortcut is that the leg squared is equal to, because again, if we were to cross multiply, so we're just looking at these parts in red, we would end up with a squared equals c times x. So the leg squared is equal to the whole hypotenuse times the part adjacent to the leg. Okay, so a squared, the leg, is equal to the whole times the part touching the leg. Y doesn't touch the leg, right? Y is over here. X touches the leg, so it's the part touching the leg and the whole hypotenuse. Or if we look at this one, it's going to be the leg squared, b squared equals c times y. So now we're looking at this leg. B squared equals the part touching b, y, times the whole hypotenuse. Okay, yes, so it doesn't matter which order you multiply, right? Okay. So let's look at an example and see how we're doing. Here is the chart that also writes it the way that I was saying. H squared equals, A squared equals, B squared equals, if you like it better that way. Okay, so here's your first problem. Now, again, what kind of triangles is this whole lesson about? Right triangles. So what other theorem do you have for right triangles, though? Pythagorean theorem. So you can definitely use Pythagorean theorem anytime that you know two sides of a right triangle and you're looking for the third. So some of these problems you'll be able to find part of the answer by Pythagorean theorem, but you won't be able to find all of the answer by Pythagorean theorem. And so that's why we're learning this. So, for example, if I were looking at this triangle right here in green, could I use Pythagorean theorem? No. I would be stuck. But could I find Z with Pythagorean theorem? Yes. Does that make sense? So I'm not going to use Pythagorean theorem, though. I'm going to practice the new theorems with you over and over again. But keep in mind, anywhere that you see you could use Pythagorean theorem, you're welcome to use Pythagorean theorem. But I want us to practice these two shortcuts. So which one do you want to try to find first, X, Y, or Z? Z, okay? So if I'm doing Z, Z is a leg, right? Agreed? So remember the rule is leg squared equals part of the hypotenuse times the whole hypotenuse. Write it down. The more you write it, the more you say it, the more it's going to stick in your brain. Okay? So if I do this, then I'm going to have what squared? Z squared equals, what's the part of the hypotenuse that touches Z? Okay, your hypotenuse is the great big triangle. So here's my hypotenuse. What part touches Z? 9. So we would have Z squared equals 9 times. What's the whole hypotenuse? Okay, good. A lot of times I have students say 9x. Be careful. You don't multiply them to get the whole. You add them to get the whole. So this would be 9 plus x. We have a problem then. We have two variables, right? So without using Pythagorean theorem, I can't solve for z first. I could do Pythagorean theorem, but again, I want us to practice these rules that we're learning today, so I'm not going to do Pythagorean theorem. So I'm going to stop right here. I'm going to need to find what first? X. So now I'm going to go over here and I'm going to try to find x. So I'm going to go to this one. This was first. I'm stuck. Let's go here. Number 2. See if we can find x. Now, to find x, you've got two options. It's part of the hypotenuse. So it's in the first formula, part of the hypotenuse, but it's also in the second formula, part of the hypotenuse adjacent to the leg. So you've got to decide which one of those is going to help you find x. If this is part of the hypotenuse, what's the leg that it's adjacent to? Y. So would it be helpful to use the leg one? No, because we don't know y, right? So it's probably better to use the altitude version. Okay, so let's write it down. It is altitude squared equals part of the hypotenuse times the other part of the hypotenuse. And again, the more you write it, the more you say it, the more it's going to stick. So what's the altitude in the picture? 6. So we'll have 6 squared equals, and then what are the two parts of the hypotenuse? 9 and x. So we're going to do 9 times x. And now we only have one variable and we can solve for x. And then we can go back and plug that in to find number 1. Is this making sense? Okay, so what would I do here? Okay, 36 equals 9x. Divide by 9 and x is 4. So we've got x. Now let's substitute it in over here and finish this one. So we have z squared equals 9 times 9 plus 4. So z squared equals 9 times 13. So z squared is equal to 117. But again, remember, what are you going to do next? Take the square root. So if you're going to take the square root, you may not want it as 117 unless that's a nice, pretty perfect square. You may want to go back and leave it as 9 times 13 because then it's easier to simplify. Does that make sense? So we already know, just don't forget that you know what it factors into because it's what you had right before you multiplied it. So this is 9 times 13. What's the square root of 9? And the square root of 13? Nothing. So this is just 3 square roots of 13. All answers should be in simplest radical form, no decimals, no rounding, unless they tell you to. Is this making sense? Okay, so what one do we have left to find? Y. Now that we know x and z, though, we could plug those in and use what? Pythagorean theorem. But again, I want us to practice these new theorems to get good at them. On the homework, you can use any of the theorems or Pythagorean theorem, okay? But just to practice, let's go back. Y now is a what in the picture? Altitude, leg, or part of the hypotenuse? It's a leg. So remember, you're looking at the big triangle every time when you're thinking about that. So it's a leg. So that means we want to use the theorem that deals with the leg. So leg squared equals part of the hypotenuse times the whole hypotenuse. And remember, it's the part that's touching the leg, so the part adjacent to the leg. All right, so my leg is what now? Y squared equals Okay, so the part adjacent to it is x, which we now know is 4, times, what's the whole hypotenuse? Okay, so now that this is 4, we know the whole hypotenuse is 13. So it's 4 times 13. So remember, it's times in the theorem, but to find your whole hypotenuse, you have to add the parts. Be really careful there. Okay, again, you can multiply 4 times 13. What does that become? 52, but you're going to have to go back and take the square root, right? So you're going to say y equals the square root of 52. So you may want to leave it as just 4 times 13. And so then the square root of 4 is 2, and the square root of 13 doesn't simplify, so it's 2 square roots of 13. How do you feel? Sort of getting it? Okay, I'll tell you, this is probably the hardest lesson of Chapter 8. It's my favorite chapter. I love Chapter 8. It's so much fun. And this is the hardest. So if you're getting it, it's going to make Chapter 8 a breeze. Okay? This is fun. The next 3 lessons are more fun than this. And I have more videos to show you with more music. So, they do not whisper. It's more fun. And actually, if you know Coach Covington, he makes an appearance in one of these. It's his twin. It's not really Coach Covington, but it looks like Coach Covington. So every time I watch it, and he's a coach in the video, every time I watch it, I'm like, Coach Covington, look at him. So you'll have to see if you see Coach Covington tomorrow. Okay, so he's a basketball coach. He teaches history here at the high school. So if you haven't had him yet, you may not know what he looks like. But all right. So here's our next example. How many more is in your notes? Is there this one, then a word problem, and that's it? Okay, I'm going to let you guys try this one on your own then. So this time I'll work in any way that you thought of. So if I have not checked your paper, I'm talking to you, okay? If I've looked at you and checked your paper and helped you, I want you to be quiet and let the ones who maybe I haven't checked or didn't have answers or are struggling answer. So first of all, somebody tell me which variable you want to solve for first. U, okay? So if I want to, is that what you said, Karina? So I want to find U. U is a part of the hypotenuse. If I look at the right triangle here that has U in it, I can't use Pythagorean theorem because I know only one side. The other side I don't know, right? So I can't do Pythagorean theorem. If I try to use one of my shortcuts, this is a part of the hypotenuse. So I could either use this one and pick a leg, and do leg squared equals part of the hypotenuse times the whole hypotenuse. Or I could pick this one and do altitude squared equals part times part. Which one of those am I going to have enough information given in the picture to solve for you? Altitude, because I know the altitude and I know the other part of the hypotenuse. My altitude is 9 and the other part of the hypotenuse is 3. So I can start and find U first by doing altitude squared equals part times part. My altitude was 9 squared equals U times 3. So that gives me 81 equals 3U. Divide by 3, and what is U? 27. Questions on the first, how to find U? Okay, it's not the only way you could have found it, but that's one way to find it. Okay, then where do you want to go next once we found U? W, okay? So I'm going to do W next. So W is a leg. I could do Pythagorean theorem now though, right? So if U is 27, I could do Pythagorean theorem. 27 squared plus 9 squared equals W squared. Does everybody see how you could do Pythagorean theorem? Okay, but I'm going to work it with one of our theorems just so you can see that being done also. So the second thing I could do is leg squared equals part adjacent to the leg. Make sure you're picking the part touching the leg times the whole hypotenuse. So my leg here is W. What's the part touching W? U, which is now 27. And what's the whole hypotenuse? 30. So I end up with W squared equals 27 times 30, and I could multiply that, but it might be faster to just take the square root and leave it as 27 and 30 and break it down. Does that make sense? So 27 factors into 9 times 3. 9 factors into 3 and 3. 30 factors into, I heard 3 and 10 first, but 5 and 6 would also work. And 10 factors into 5 and 2. Don't lose any of your pairs. So I've got a pair of 3s here, a pair of 3s here, and a 5 and a 2 left over, which means this is going to simplify to what? 9 square roots of 10. Now, since you'll have a calculator for problems like this, I would probably type in 27 times 30 and take the square root and make sure it's not a perfect square first. Because if it's a perfect square, you just spent a lot of time simplifying it when you didn't need to. You could have just typed in your calculator. But if it gives you a decimal, then you're going to go back and say, nope, factor it back down and leave your answer. Does that make sense? Okay. And so then to find V, you could go back and do Pythagorean theorem. Or V is also a leg. So I'll do it by the other method. Leg squared equals part times whole. V is my leg, so that's V squared equals. What's the part touching V? 3. And what's the whole thing? 30. So now we have V squared equals 90. Take the square root. And 90 factors into 9 times 10. And the square root of 9 is 3. So this is 3 square roots of 10. Questions? Yes, V equals. Yes. Yes, make sure you identify which one's which. So W and V. Javi, questions? Not good. Okay, so let me throw up on the board. Yeah, throw up on the board. Let me throw up on the board. I'm sick of this now. Let me put up some examples real quick to see if you can get how to write the equations, first of all, okay? So I'm going to write some things down here just with variables. Let's do X, Y, Z, W, V. Okay, Javi, I want you to give me the equation using those variables for the first shortcut, altitude. Altitude and the parts. I want you to tell me what it would be for this picture. Okay, that's a Z, but Z squared. Y times W. Okay, so that's your first shortcut. Do you see that? Altitude squared equals part times part. Every time. Altitude squared equals part times part. Okay, Edwin, give me one of the rules using this leg X. So we're using, for the leg, so it's leg squared. So what would I write down using this leg X? Equals, and then it is whole hypotenuse and the part touching the leg. Times. And make sure you put that in parentheses so that you distribute the Y if you need to. Okay, Edwin, do me the same thing, but do it for the other leg, V. Does that make sense? Javi, does that make sense to you? Okay, so the goal is to look at the picture and write down your theorems and then pick the ones that you have enough information for. So if you start with this one and you have a Z and a Y and you can't solve it, then go to a different one. Try it until you solve for the things you need to go back and find the other ones. Yes, there's always 2 legs and 1 altitude. So there's always 3 different things you could write down on your paper, and then you could do Pythagorean theorem for some of them. But I'm telling you, you won't have enough information to do Pythagorean theorem for the whole process. That's it. Okay, one last word problem. Let's try it. See if it gets clear, and if not, I'll come help you individually. Last problem here, okay? So a surveyor positions himself so that his line of sight goes from your eyeballs. If you have a word problem on your homework, think from my eyes. His line of sight to the top of the cliff. So here's the guy, here's his eyes to the top of the cliff is, so he positions himself so that the line of sight to the top of the cliff and his line of sight to the bottom form a right angle. So now here's his eyes, now he's looking down at the bottom, and this is a right angle. Okay, so there's his line of sight. His line of sight, if he goes straight across, then becomes what in our big triangle? The altitude. Okay, that line is the altitude. Is everybody with me? That's the altitude. Okay, so it says, what's the height of the cliff to the nearest foot? So they tell us this part right here is 5.5 feet. So if we want to find the height of the cliff, what are we going to have to find in order to get the whole thing? What's x? The other part. So from here to here, right? Okay. And then we can just add x and 5.5 to get the whole cliff. Agreed? Okay, so we're looking for this. Here's our right angle. And we know the altitude is 28. So which shortcut are we going to want to use? The altitude squared equals part times part. Okay, so what would I write down for my equation then? Guys good back there? Okay. Cindy good? Okay. So then from here I'm going to square that and then divide by 5.5. Okay, you've got a calculator, do that. And it says to the nearest foot, but let's wait to round until the very end. So what is 28 squared divided by 5.5? Okay, so x is 142 point, okay, 54 repeating. And then I'm going to add that value and 5.5. So go ahead and add 5.5 on your calculator. Don't ever round until the very end. So keep the number in your calculator, add 5.5, and then round. So what is this when I add 5.5? 148.04, blah, blah, blah. And it says to the nearest foot. So, so what is my answer? 148 feet. All right, this is the one that I always worry.